general relativity, step by step. Right, we've got this equation here which links the Christoffel symbol lambda to the fundamental tensor and its derivatives. I need an expression for lambda on its own, so I want an expression for that, which is the Christoffel symbol of the second kind in a particular coordinate system. What I'm going to do, I'm going to define something slightly different. I'm going to define this, which is going to be the Christoffel symbol, but lowered. I'm going to lower, going to contract on an L, that's going to be an I, what's left? A J and a K. Excuse me. Okay, so I'm going to define these guys here. So that's contracted, that's summed over L, of course, because we've got an L on downstairs and upstairs. So what I'm going to do, I'm going to have my equation here, dij by dx equals, and then of course by definition this is, let's get it the right way around, the index I is there, the L's gone and that's a jk, plus, that's that term there, this term here, the L's gone, it's a j I k. There we go. Now what I'm going to do is I'm going to work out dij by dx, and I've got a k on the bottom. I'm going to put everything on the bottom in turn. So I've got a k there, I'm going to have an I. What's left here? We've got an I and a j, so that's going to be a j and a k. That's going to be something. And I'm going to have a dij by dx. We've got a k on the bottom, an I on the bottom. It's going to be a j on the bottom. What have I got left? I've got I and k here. And I'm going to make these a minus just because, actually I won't, I'll change the sign later. Okay, so they're all these guys here, and I'm going to arrange everything so stuff cancels out in pairs, and then I'll get an expression for my gamma terms here. So it's ijk, and see what's the difference between this term and this term here? It's just that the first two indices swapped over. So we've got ij, which is that index I and j are the subscripts on the fundamental of the metric tensor here. So that's going to be jk, and then the other one. This one here is going to be kj, and then I, plus that. What have we got? That's ik, and then a j, and then we are going to swap over the first two indices, k, I, j. Now what I'm going to do is I'm going to make an assumption which is kind of, it's not controversial exactly, but I'm going to say that we're going to work on torsion, no it's an S, torsion-free system. So I'm effectively going to assume that gamma of ijk, actually I'll write it down for the symbol of the second kind. I'm asserting that that equals ikj. So it's symmetric in those two indices here. So that says in terms of the symbol with three lower indices that ijk downwards equals ikj. So of course torsion free is that's physics. There's no reason mathematically to assume this. I think a manifold is torsion free if it's embedded in a higher dimensional space, but I'm not sure that you can embed space-time, certainly near heavy objects like black holes and stuff. It's not clear that you can embed that four-dimensional space-time in a higher dimensional space. So I'm just going to assume that the system's torsion-free. It makes the mathematics much easier, and I don't want to cover torsion anyway. So what I can do is basically I can cancel out this term with, that's ijk, with this term here. So of course I'm going to make these signs a negative, and I'm going to change that sign to a minus. That's a minus. I'm going to make that, oops, I'm going to make that a minus and make that a minus as well. And I'm going to add these together, and I'm going to get some cancelling going. So let's have a look at this. I'll change to red. I'm going to cancel that one with that one through torsion freeness, torsion freed. JIK, which one does that cancel? Oh no, it's this one that's going to cancel out, isn't it? Oh no, that one and that one cancel. And these two guys are equal because they're KJI and KJI. So let me just go back to black. Here we are. I'm just going to add all these three equations together. I'm just going to add all those three equations. I'll pinch in a little tiny bit. So I've got di Gij by di xk, which is this term here. I hate it when it does that. Minus di Gjk by di xi, which is that term there, minus di Gik by di xj equals 2 gamma k ij, because these two guys here are equal. So that's nice. Oh, no, minus 2. Minus 2. It's easy to get these signs wrong. Minus 2 times gamma kij. So that tells me that gamma kij equals 1/2 of curly d. Oh, I've been told I shouldn't say di. I say di g by di xj, but I shouldn't say that. That's that term, plus this term, di curly d jk by di xi, minus this term here, because I'm changing the sign of everything. Di curly d ij by di x. Doing it again. Di is a nice word. I like it. Well, that's great. Now, but that's the symbol with the Christoffel symbol with all three indices down. What I need to do is to think about this guy here and think how I can get back. I'll write it out. I'll write it out again here. So what I've got here is ijk equals gli ljk. And I've got this guy here. I've got this one. I've got this because it's here. And I want this. So what am I going to do? What I'm going to do is I'm going to raise one index here. I'm going to raise an index here. So what I'm going to do is multiply. I've got this. I'm going to go down. I'm going to write that again. We've got that. ijk equals gli ljk. I'm going to multiply by a contravariant index. I'm going to kill the L. Kill the M. I'm going to multiply both sides by GLM. Sorry, I'm getting myself tangled up. I can't kill the L because I've got two L's already. I want to kill the I. So I'm going to multiply it by IM and put an IM here as well. Sorry, I'll start that whole thing again. We've got gamma ijk equals gli ljk. So what I want to do is to isolate this guy here, which I've got, and I've got this guy. So I've got two L's, so I'm going to multiply by contravariant IM, and I'm going to multiply on this side by IM. And I'm going to make the observation that this guy here, just by construction, is delta ML. So what have we got left? We've got that GIM IJK equals delta ML times the Christoffel symbol that we want, which is this. And of course that's equal to MJK. GIM gamma IJK. Well, that's quite nice. So the M is a free index, it's summed over I on the left hand side, and J and K are subscripts on either side. Okay, so now I can start applying this. So which way round is it? We need to contract with the first index and leave the second one free. Let me re-change my indices here. No, well actually I'll just multiply it on. I'll just multiply I'll just excuse me. Right, I'm going to multiply on the left by, I'm going to contract with k and m. So we've got g k m k I j equals a half, and then multiply on the left by km di g I k by di x j plus di, I'm saying di again, I shouldn't, k by di x, why not, I'm going to say di anyway, sue me, j by di x k. There we go. So that tells me that the Christoffel symbol, k's of contracted m I j equals this thing here, a half gkm di g I k by di x j plus di g j k by di x I minus di g I j by di x k. Contracted over k. You don't normally write it like this. You normally write it in slightly different notation. You just change the change the index names. So I'm going to write it. You normally write it like that. Oh, you can do it how you like. Equals a half, and then g. We've got I, j, k, and then contract on an L. So the I is free upstairs there. It's contracted on an L times the differentials. I'll show you how I write it down. It's di g something something by di x something plus, di is such a good word, di x, and then minus the last one, di g something something by di x, close the bracket. I'll get rid of this lot as well while I'm about it. Just a minute, let me just move that over there. Right. So, let me think about this. Let's think about this. I'm going to change the index names. We've got the I is free on the top. So that I is this I here. L has got to contract with, there's one of three places it can be. It can be there, or there, or there. And the L being on the differential down here means that it's got the different sign there. What indexes have we got left here? We've got a J and a K. It's got to be a J and a K, or a K and a J, or a K and a J. Can you see how this term here is different? Because the K and the J that are free on the left hand side are both attached to the metric tensor in here. Whereas in the other two terms, in this term and this term, the K and the J are split between the metric tensor and the differential. So that's quite nice. That's nice. I'm going to stop there. I think that's wonderful. Stop.